Hello, I just have to shoot this video because it's kind of a cool little duh moment when it comes to writing some code. Recall the one you just saw a little bit ago. The robot was real jerky and I was bouncing around, and I was looking at trying to streamline a little bit, and then I realized something well, really simple, and it's worthy of sharing. So again, super fast. I've explained this in the last video. I've got my variables that are going to hold the information from the receiver as it comes in to each of the 6 channels. I've created these 5 different objects. One of them I've labeled a DC motor because I'm going to hook up a motor controller to it. If you want more details, look at the other video. I've set my 6 pins that are going to be hooked up to my Airtronics right here. The 6 pins correspond to the 6 channels out. I've set them all to input, and I've attached these devices. I have 4 servos hooked up to these ESRA arms, and like I said, I've left this one here. Turn on serial, and we go down to this loop. And this is the cool part. So if I were to turn on my transmitter, and the antenna's up this time, and oops, turn on the COM port. Alright, you can see, look at channel 0, wait for it to go down. Channel 0 works just great. Okay? And I was sitting there thinking, well, you know, this is pretty nice, pretty fluid. Let's see if we can smooth this out. So what I said is, well, let's look at this. This time here, this is 25,000 microseconds, or 25 milliseconds. That's how long it's going to wait to receive the leading edge of the serial communication. So it's going to give it 25 milliseconds, and then it's going to time out. So, well, you know, I don't got it. All right. So if you servos, I have a whole video on this, which maybe I'll put a little link on here. In brief, servos work by pulsing at 1 to 2 milliseconds with a 20 millisecond delay. So if it's at 1 millisecond, the servo is going to be at its maximum, say, in the counterclockwise position, and at 2 milliseconds it's going to be at its maximum in the clockwise position. 1.5 milliseconds, and it's straight up. Anywhere in between, you can put it in any position. Okay, so I thought to myself, well, let's see if we can trim this down. And it's actually kind of amazing. Not really, actually, in hindsight. I'm going to set this to 19 milliseconds. 19,000 microseconds. And lo and behold, when I load this in, Control Shift M, transmitter's on, I get gibberish. See that? Some of them are working, some of them aren't. It's actually the channel 0 seems to be working, but it's lost to channel 1. Channel 2 seems to be working, lost channel 3. Channel 4 seems to be working. Well, channel 5 was never hooked up anyway. I'm starting to lose my signal. Oh my goodness. Alright, well, let's go to 20 milliseconds. Remember, that is the idle time for a servo. And by no surprise, we're going to find, at least I certainly hope so, that if I go 20 milliseconds and open up my little window, it's back again and it works. Okay? So now I'm back to having complete control, and it's able to interpret it. So that basically means that each one of these things is going to be a around 20 millisecond wait for the leading edge, which doesn't really come as a surprise because servos are designed to wait 20 milliseconds between pulses, which ultimately means we're going to play it safe. I'm going to bring that back up to 21 just in case. Give it an extra millisecond there. But where that really comes into play is up here in my drive servos. I'm in such a habit of putting a 20 millisecond delay in between pulses that, you know, it's silly. I'm already way over that, down here, this is taking, 20, 40, 60, 80, 100. We're talking 100 and some 120 milliseconds going through all those 5 pulses, waiting for the leading edge, and there is no reason at all to add another 20 millisecond delay there. Okay, so if I just rem that out, it's going to get smoother. And actually, I'm going to load this up, and we can see we've still got a nice signal. Okay, and now let's go ahead and make it run servos. Keep in mind, don't look for anything super here, because because you're not going to get it. It's still too long. It's still going to be jerky, but hopefully it'll be better. Okay. By the way, this part of this quivering is just because there's not enough mass. It's just kind of floating around. But you can see now I got, I've got my control. It's better. But if we want to make it even better, well, that's not too terribly hard. Let's ram out a couple of these. And so we're going to get rid of a 20 millisecond here, 21 millisecond. We're going to get rid of another one there. So we're still going to have just these 4 servos, and I would expect it to get even smoother. Okay. And lo and behold, look at that. It's definitely smoother. Okay, we're getting closer. We're getting rid of that delay. It's getting more fast acting. So ultimately, what that means is to get a really seamless thing, we're gonna have to be looking for changes. We're gonna have to look for some sort of interrupt or some sort of change in signal. And again, like I said, I may not even worry about that for a while. Let's keep this code simple. It's perfectly functional for what I need to do. But I thought I would explain this this delay here, as well as this getting rid of this unnecessary delay, which is just adding time to something we already have too much of. And that's it for the moment. I'll load this one up as well shortly, the code onto our page, and I will see you soon.